Hey, welcome back all. Uh, this is the second video, second table format in this open table format. That is an Apache Iceberg format we are going to see. In this video, we basically look at the table structure, how it will be stored, the data in the file system, and what is the metadata created as part of this Iceberg table, and also we'll look at the data files uh, of how they are laid out. Okay, so this is we'll see in action, and we'll create a Iceberg table, and then we'll look at the metadata for it. So for this one, I have created a project in my GitHub repo, and then the project name is Iceberg Spark Java. This code base, you can take it and just simply run in your local machine. So one prerequisite for this code to run it is set up the Spark environment in your local. That I have another video in beginning of this series of this open format. You can refer that. I'll give a link in the description too. Having said that one, let's get started into the table formats of the Iceberg. So what is the Iceberg? So it's another table format where the way it will organize the files in a different compared to the other file format, the hoodie. So each one has their own advantages and limitations. So we can go through that at the end, but for now let's go and understand the what is there in the Iceberg table. So Iceberg table, at the core level, it will have in the bottom, it will have a data layer. So that is where actual your data files related, the way you store the data gets stored. These data files can be of your choice, either in Avro files or Parquet file or ORC files. So, but the default format is in a Parquet file, because that's a columnar format file that will give a better performance for these analytics workloads. And these data layer have three kinds of files. One is a data files, and the second is a delta files, and the other is a puffin files. So data files is where actual data gets stored, and delete files is, let's say you have deleted some row from your table, then one row, that deleted row entry gets created in the delete file. So they call it a delete file. Along with these two files, there is another file called the puffin file. So this puffin file is used for, it will store the lot of metadata that will help us to query engines to do a better query planning. So these data files and delta files, they do have the metadata, but these puffin have the more data, more metadata of these data files and delta files, and the data that is getting stored in this table, so that the query engines can leverage these puffin files to do the better query planning and execution. So that's a very high level about the data files. So just to remember that in the data layer, there will be three kinds of files: data files, delete files, and puffin files. We'll see them in action. Okay. So in the metadata layer, we have a different three different kinds of files. These are three kinds of files we have. That we have we have the metadata file. This is the one file, and we have the manifest file list. This is another file, and the other one is a manifest file list. This is the hierarchy of these data, these files, and this is how the one file is reference to the other files. So when we started the data files will have the data that table is owning, right? And these data files information need to be get stored. Metadata related to these data files: path, what is the starting record, ending record in these data files get stored in a file called that manifest file list. So manifest file is a metadata about these data files. And then we have a different manifest file for a different data file. So these manifest file information gets stored into a file called the manifest file list. This manifest file list is where path for this manifest file gets stored, and also some of the metadata related to these manifest files. And these manifest file list uh, get stored into called the metadata file. Before go to the metadata file, just observe the difference between these two layers. So this is a manifest file list, and this is a manifest file. This is in a single file, but a set of manifest files get information gets stored in the manifest file list, as the name says. And this manifest file information gets stored into a file called the metadata file. And these metadata files are called the snapshot files. So these metadata files help us to find the table in structure the data in the lifetime of the tables called the snapshot. So that information will be used to get the snapshot of the table, latest information of the table, and that also to find the historical information of this table. And along with these three files, these three layers, we need another layer, that is a catalog layer. In this catalog layer, you should have information pointing to the database table name to this metadata file pointer. So this table is having a metadata files in this location of this file gets stored. That is gets stored in this Iceberg catalog table. So you may be overwhelmed with this information, but let's get see it in action. We can easily relate. Okay, so for this one, I have using my project this Iceberg Spark project. So here I have a plain Spark code. What is that it is doing is I said this Hadoop home directory, and then there are to enable the Iceberg extension in our to our Spark program. We need to enable set of extension like the Spark SQL extension. That should be the Iceberg Spark extension. This Iceberg Spark extension is an extension of the core Spark extension session. And then we need to set the catalog. So for this example, I'm going to do the catalog of local Hadoop catalog, and the type is going to be Hadoop. Means it's going to store that catalog information that we saw it in this diagram, right? So if you see that we have an Iceberg catalog, right? That is the information we are saying, that you store this catalog information like the table to this mapping in the uh, Iceberg in a local file system, because I don't have any other cloud S3 to store or Hive Metastore to store this. So I'm storing it here. That's why I put it as an Hadoop. Hadoop is like any file system. And then metadata, the like when the table data gets stored, where it needs to be stored, that information is we are going to store in this location. So these are the set and mandatory parameters we need to enable for our Spark job to create an Iceberg tables. Once you've done that one, so you can go and create a table using the Spark SQL. I created a Spark session. I'm using the Spark SQL where I'm doing creating a table. This is the table format. So the first one is the catalog name. So we have the catalog defined as a local, right? So we need to have the catalog name as a local, and the database name is I created as a data DB, and maybe let me put database name as an Uber. Hmm. And then this is the table name. Let me put as an a trips. So this is this is the format of the table, like the schema name, sorry, the catalog name, that is going to be our Spark catalog, local catalog, and the schema name, that database name, and the table name. So let's go and create, let's go and check if we have anything in this directory path. So Spark warehouse, I'm going to show, so this one, Spark setup. So here I have the path we have is the dspark setup. That's inside that we have an Iceberg, right? So let me go and delete this one. So then we don't have anything here. So that when we run that, it should create. So let's go and create this table and see what will happen. So if you see that under the Spark setup, we don't have any directory called the Iceberg. This is what we are seeing. Okay, let's run this one to see whether it's generating any file. So this program, while it is running, let's go back to this directory. You see, the directory got created. The timestamp is like 1102. And if you go inside this directory, you have the spare warehouse directory, because that's what I mentioned, Spark warehouse. And then I have mentioned this metadata directory. I mean, this directory path you can set to anything of your choice, but this is the base path for my warehouse. And then under that one, I have my table as an Uber, right? So that's what information gets directly got created, Uber, and the table name is the trips. That's what I see. That you don't see the local table name. This is a logical name used by the Spark, but for these database and tables, you will see the directories. That's what you are seeing, that Uber and trips. And under this trips directory, you have a directory called the metadata. So this metadata will have the information related to this table. So when we created the first time, right, the table first time get created. So there is a metadata file gets created. This is the v1 dot metadata. So to relate this file with this architecture diagram we are seeing, so this is the metadata file for the v1 v1 dot metadata is the one we are seeing it here, metadata file. Okay, so let's open this and see what is information is there. So if I open this one, uh, so let me bring this here. So if I see this one, this is the v1.metadata JSON file that we are seeing it here. That's created as when we created the table. It will have certain information. So it will have the format version. This is internal to this Iceberg, and then it will have an ID called the table UUID, and where this table gets storing the data, like the location of this table in where it's going to put the data files. And then it will have the schema that is pointing to the column names that we mentioned. I have mentioned the certain columns and the data types and the order, like in which order they are getting stored. Along with one, we mentioned the partition information, right? That partition information gets stored here, like the partition name, and this is internal to this, but it's basically a partition name. That's what we have it here. And then it will have the some of these table properties, like the compression to use and current snapshot ID is a -1. So this value gets updated whenever we do any operations on the table. So this is the plain metadata file that's got created as part of the when we created the table first time, and it will not have any other files. That's just the plain data. So now let's go and insert some data into this table and see what will happen. So to do that insert, I have created some Spark program that is going to be insert some data into this table. So I created it. So these is our plain Spark program. Again, I'm using the warehouse, right? So we need to set the warehouse Iceberg, right? Iceberg properties, that local directory path. That's a warehouse directory path. And then I'm creating a Spark session. And here I'm inserting, creating a structure for my table. And then I'm creating some dummy records. And then I'm inserting these records into the tables, and we'll see that. So if you see here, we have the under the trips, we have the metadata. Under the metadata, we have this v1 metadata .json, right? Here we don't have any data file. Here we don't have any data. If you go inside here, we just have the v1 metadata. So let's go and insert some data and then see what will happen. So if I run this one, let it run. So while it's running, we can go here and see that if there is any new files are showing up here. Oh, I made a mistake. Table not found. Okay. What is the table name? Local creator replace. Oh, okay. I need to put this some metadata information here. I missed to add it. Okay. So let me go and run it. I'm not editing the video because I want you to see the mistakes we make as part of when we are trying to learn a new technology so that you will understand. So, okay, let's get created. So it's created some data file. You see that the time is 11:07. If you see that certain files are get created in this time frame. So it's created, and also it's created another file called the metadata v2.metadata version. So what is this metadata? Let's start with this metadata version. So okay, so before we go to the inside the metadata version, so let's see that we got some new data, new files created in the under the metadata directory, and you see here we have another data folder is get created. So let's go and see what is there. I have the data because I have the data partition by the city. That's why it's showing created a directory instructions like this. And then inside that it's created the parquet file. Parquet files, and these are CRC file. Ignore them. So these are the parquet files get created. So when we insert that one, it's created a data directory and then inserted the uh, it's inserted these data created the data file and then directory, and in the under the data directory we have the different folder that stores the data, and the metadata it's created a new metadata JSON file, right? Let's get and open this file and see what is there and compare the difference between the previous version to this version. So here I can do some compare tool. No, this is not. Mhm. So let me store this file. Okay, let me compare this one. So if you compare this one, version 1 to the version 2, so the timestamp value got updated and the sequence number is also got updated, and also some of the new metadata snapshot information got added. So in when the first time the table is created we have the -1, but now we have the current snapshot ID got created, and some of the snapshot information gets stored here. Okay, and it's showing that how many records got added because as part of this stamps snapshot creation, and some of the information gets stored, and what is the data snapshot file information, and this is the snapshot file got created as part of the insert statement. So that's about the it basically create a lot of metadata information related to our insert. So if you see this one in this directory structure, we have this two two files, two Avro files got generated, right? Let's go and see that what is there in these Avro files to understand the better of this architecture we saw. So I have a program called here, and then I'm going to read some Avro files of this one. So I'm going to read Smart Warehouse metadata. Okay. I'm going to read the Avro file. Uh, mm, so let's read these metadata files to understand what is there. So let's read this snapshot file first, so that we can see that what is there in the snapshot file, and then we can see what is there in this other file. So okay, let's run this program to see what it is showing. I think I need to set this one too. I'm reading these metadata files those created as part when we do an insert so that we'll understand. Oh, okay, it's failed again. Path not found. Okay, Spark setup, Iceberg, Spark warehouse, metadata, Uber, metadata. It's talking about this 970. This file is not there. Um, Okay, let's get create run this program to get some what is these Avro files are showing. So okay, it's show the output of those two Avro files, right? Okay, let's copy them in a Notepad Plus so that we can review them. What are these entries? Okay, that is about one Parquet file output, and this is another Parquet file output. Okay, let me go and do the what. See. So let's start about this snapshot file. So what is the snapshot file is saying that it is pointing to this. It will have a manifest file path column and then some metadata related to that manifest file, like what is the snapshot ID. This is the snapshot ID we saw in this uh, main metadata JSON file. So that is mapping to this add snapshot file. And this snapshot file will have the metadata file path. What is this? This is the metadata file path. This is the file. The output of this file is the above output. So if you see this one, this output file, this snapshot file have the manifest file information, and these are the manifest files. So you see, this manifest file have path of the data files. These are the path for the data files. So to relate this one, to relate this example, this metadata file is this metadata JSON file, and it will have the information of the snapshot S0 S1. So it will have the information of the snapshot IDs. And this snapshots basically point to a manifest file list. So that manifest file list is this one. This is the manifest file, and this manifest file, the manifest file contain the actual path of the data files. So this manifest file contain the path of the actual data files. So just to recap, so we have the metadata JSON file that is pointing to the snapshot, and the snapshot file will have the snapshot file is basically manifest file list, and that manifest file list is this one, and the manifest file have the manifest file path, and this manifest file path output is this one, and the manifest file have the actual data files path. This is the hierarchy of the table structures it maintains in the Iceberg tables. So yeah, this is a high level, very quick introduction about the Iceberg metadata tables. We as we get inserted into the as we get do the more insert into the tables, the table it will create these new metadata files. These metadata files get new metadata file get created, and then the respective snapshot and these meta file list got created. For each updates on the table, insert, update, delete, everything will create a new metadata file. That information will be used for the time travel, historical status finding, schema evaluation, partition evaluation, some of the benefits we get because of this extensive metadata. We'll go more some of the features of the Iceberg in the coming videos. For this is the hierarchy of the metadata for this video. Thank you.